Trigonometry is a well-taught and well-known branch of mathematics that has heavy applications in the real world. It is a highlight of this course which helped to understand how trigonometry relates to unit circles, general triangles, angle measures, mapping sinusoids/waves, and geometric figures in general. Thus, it was interesting to see the great scope and range of applications that trigonometry has in the real world. Trigonometry and its concepts is the result of great minds applying knowledge built upon one another to create the collective information known today. The earliest uses of trigonometry could be seen with the ancient Egyptians and Babylonians, who applied its concepts for measurements and construction. From engineering to forensics, the functions of trigonometry serve many uses for many individuals, showing that math is really depended on in the world as we know it. The use of math at any level should never be undermined, and its applied functions should always be considered, as math plays a heavy role behind the technology and society we inhabit. Like many mathematical concepts and branches, trigonometry contributes greatly to the field of engineering. One particular example is in aeronautics, and trigonometry aids extensively in ensuring safe and calculated landings of aircraft. A descending aircraft needs to safely communicate with intel to calibrate a designated landing, and this could be done with the use of trigonometric functions, given the information theta, or the angle of descent, relative to the horizon, and the vertical distance between the aircraft and ground. This is usually found with radar. The base equation determined through the use of trigonometry is then further applied to take into account factors such as wind velocity, weather conditions, air pressure, etc. As a large part of trigonometry is about finding missing angles and sides, it is no surprise that trigonometry would aid in the fields of architecture, civil engineering, and construction. A truss bridge is a bridge that works well in distributing pressure and load through compression and tension points. This is done through the use of diagonal and vertical beams attached to the deck. These shapes create the form of isosceles, equilateral, and right triangles. As many triangles form the bridge, it is necessary to know angles and side lengths of its components in order to safely test and ensure the stability of the bridge. Trigonometric functions can often be applied to all triangles, not specifically right triangles. While it would be possible to map out the side lengths of each side length, component, and angle measure, it is more convenient and time-saving to use trigonometric functions to quickly find desired variables and measures. Many waves can be identified as sinusoidal, which means they have the form of a sine curve. Other waves that may have areas and components, which can also be mapped as sinusoidal, so the sine function serves as a good base for mapping waves. Sine curves are then adjusted or transformed to meet the form of the wave given for components such as period, amplitude, wavelength, and frequency. Sound notes and pitches are often represented as sinusoids, and thus can be given a sine equation representing the wave's form. Given transformations include vertical/horizontal stretch and shrink, vertical and horizontal translations, and reflections. Trigonometry is also a helpful tool and resource used by oceanographers to calculate and predict how intense wave tides will be. While waves are not perfect sinusoids, its form can be closely mapped by sine functions. Similarly to sound waves, the sine function is usually manipulated to more accurately match the trough and crest of the wave tide. Since the wave's properties may change significantly at different points of the tide, the graph can be split into sinusoidal components. Interestingly, trigonometry also has applications in criminology. Trigonometry can help to calculate the trajectories taken by projectiles. However, its most extensive application is in forensics. Blood splatter is often left behind at the scene of a murder or crime. Given the location of the blood splatter, it may provide useful information given the position of the assailant, victim, and other factors. The form taken by the blood splatter and droplets will determine the angle of the droplets' path relative to the surface. With that information, one can estimate and find information such as where the victim may have been standing, areas of attack, and the source of the blood. Surprisingly enough, the use of trigonometry dates back far in history. and celestial navigation is one of the earliest uses of trigonometry. Prior to modern navigation techniques, one way sailors navigated through oceans was through the use of a sextant. A sextant maps between the horizon line and celestial bodies in relation to the time of day. Predetermined knowledge was also necessary in addition to the use of a sextant, such as knowing that a particular star in the sky leads north or the direction to which the sun points during the time of day. Distances were also pre-measured to help sailors more easily navigate the seas. As a result, using relation angles, sailors could determine distances and set a course direction.